Now, touching on the last part where we were looking at several equations and whether or not they were functions, we have a formal way of identifying functions by looking at graphs, and that's called the vertical line test. If no vertical line can be drawn so that it intersects a graph more than once, the graph is a function. And so we're looking at that idea that when I pick any x value denoted by a vertical line, as long as that x value does not match with more than one y value, then we know that it's going to be a function. So let's take vertical lines. Let me set this to 90 degrees. And just imagine as we go across this linear equation that's shown here. Well, if I take this vertical line, I am never touching that purple line of our equation more than once. And as a result, that means it passes the vertical line test. Passes the vertical line test. Actually, let me move that over. Passes the vertical line test. I can draw a vertical line, and it's never going to intersect more than once, meaning it is a function. But if we take a look at this next graph, we pass a vertical line, and we see pretty quickly that we are intersecting our graph at more than one place. Therefore, it is said that it fails the vertical line test. Therefore, it is not a function. We can continue, and we could take that vertical line, and I'm never touching this curve more than once. So we are passing the vertical line test here. This one passes, meaning it is a function. But our circle here, it fails pretty quickly the vertical line test. This one failed, so it is not a function. Here we actually have a fourth degree graph, fourth degree polynomial, x to the fourth power. And while it has a lot of ups and downs, if we look very carefully, we are never touching this graph more than once, no matter where we go. And so it passes the vertical line test, meaning we have a function. And this last one is an x to the third power. And while it may look a little touch and go here in the middle, it levels out, and we are never touching this graph more than once. Therefore, this one also passes the vertical line test, denoting it as a function. And with our functions and relations, we can also identify and find the domain and the range. Now, these are continuous, so we're going to have to use interval notation to identify the domain and range. Interval notation. So we'll take a look at the domain and range, and we have to think about, for the domain, again, that's all of the x values. And so we look to see, well, what's the lowest x value and what is the highest x value? Well, our x values go from -3 to 5, so our interval is -3 to 5. And actually, we need those in brackets because -3 and 5 are both included within our domain. Notice the closed circles on those points. Now let's take a look at range. Let's get a little bit brighter color. Range refers to all of our y values. So we want to look at the y-axis and see the highest point on the y-axis and the lowest point on the y-axis. Our range goes from -2 to 4. -2 with a bracket to 4. And we can look and see that our graph passes the vertical line test. Therefore, it is a function. And we can look at our oval that we have here. And let's identify our domain first. X values extend from -4 to 4. And then our y values extend from -2 to 2. This graph fails the vertical line test, as we can see just by the y-axis. So therefore, it's not a function. Our next graph here, we look at our domain, and we see while we run out of space on the graph, we notice that our arrow continues going to the right and to the left. So our graph is going to continue forever in the left and right dimensions, meaning that our domain is from negative infinity to infinity. It is all real numbers. Our range starts at 0, but it does continue up forever in the positive direction. So our range is from 0 to infinity. And then with our linear equation, and we'll answer that it's a function. It passes our vertical line test, so it is a function. And then lastly, we're looking at our linear equation. It's continuing in both directions on the x-axis. So our domain is negative infinity to infinity, also known as all real numbers. And it's also continuing up and continuing down forever, so the range is also going to be negative infinity to infinity, or all real numbers. Now our linear equation always passes the vertical line test, so again we have a function.